Preparing for a .NET developer interview. You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer, followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What happens when a .NET application is compiled and executed? .NET code is first compiled into intermediate language, or IL, inside an assembly with metadata. At runtime, the CLR loads the assembly, verifies it, and uses the JIT compiler to convert IL into native machine code. The CLR also manages memory, exceptions, type safety, and security. This separation gives .NET portability across runtimes and lets the framework optimize execution dynamically instead of compiling everything directly up front. While answering, focus on compilation to IL, role of CLR, JIT compilation, metadata, assemblies, runtime services, and why this model enables portability and managed execution. Question 2. What is the difference between .NET Framework, .NET Core, and modern .NET? .NET Framework is the older Windows-only platform widely used in legacy enterprise applications. .NET Core was the cross-platform, open-source rewrite focused on performance, modularity, and cloud workloads. Modern .NET, starting with .NET 5, unified the ecosystem under one platform for web, desktop, mobile, cloud, and APIs. For new development, I choose modern .NET, unless there is a dependency on older technologies like web forms or WCF server hosting. Make sure to cover platform support, performance deployment model, open-source evolution, compatibility, and when legacy .NET Framework may still appear in enterprise systems. Question 3. Explain the difference between value types and reference types in C#. Value types store the actual value and are copied by value, while reference types store a reference to an object. Structs, enums, and primitives are common value types. Classes, arrays, and strings are reference types. The practical difference is mutation and copying behavior. Passing a struct usually copies data, while passing a class copies the reference. Boxing can occur when a value type is treated as object, which may add allocation overhead. In your answer, talk about stack versus heap behavior carefully. Copying semantics, boxing, nullability, structs, classes, records, and performance implications without oversimplifying memory allocation. Question 4. How does garbage collection work in .NET? .NET garbage collection automatically reclaims memory for objects that are no longer reachable from application routes. It uses generations because short-lived objects are common, so Gen 0 collections are frequent and cheap, while Gen 2 collections are heavier. The GC marks live objects, reclaims dead ones, and may compact memory. I still dispose unmanaged resources using IDisposable because GC handles managed memory, not database connections, file handles, or sockets deterministically. Be sure to mention managed heap, generations, routes, mark and compact behavior, finalizers, IDisposable, large object heap, and how developers can reduce GC pressure. Question 5. What is the difference between disposable and a finalizer? IDisposable provides deterministic cleanup. I call dispose directly or use a using statement when I am done with a resource. A finalizer runs later on the GC finalizer thread and is not predictable. That makes finalizers expensive and unsuitable for timely cleanup. For database connections, streams, and handles, I prefer IDisposable. If unmanaged resources are involved, I follow the dispose pattern or use safe handle to avoid fragile cleanup logic. While answering, focus on deterministic cleanup, unmanaged resources, using statements, finalizer cost, dispose pattern, safe handle, and why finalizers should not replace proper disposal. Question 6. How do async and await work in C#? Async and await let me write non-blocking code in a synchronous-looking style. The compiler transforms the method into a state machine and returns a task. When an awaited operation is incomplete, the thread is released instead of blocked, which is ideal for I/O like database calls or HTTP requests. Exceptions flow through the task and can be caught normally. I avoid .result and .wait because they can cause deadlocks, and thread starvation. Make sure to cover task-based asynchronous programming, non-blocking I/O, state machine generation, synchronization context, exception flow, and common mistakes like blocking with result or wait. Question 7. What is dependency injection, and how is it used in ASP.NET Core? Dependency injection means a class receives its dependencies instead of creating them internally. In ASP.NET Core, services are registered in the DI container and usually injected through constructors. This improves testability, separation of concerns, and configuration flexibility. Lifetimes matter. Singleton lives for the application, scoped lives per request, and transient creates a new instance each time. I'm careful not to inject scoped services into singletons because that can create lifetime bugs. In your answer, talk about inversion of control, constructor injection, service lifetimes, testability, built-in container, and choosing singleton, scoped, or transient correctly. Question 8. Explain middleware in ASP.NET Core. How does the request pipeline work? Middleware is a component in the ASP.NET Core request pipeline. Each middleware can inspect, modify, pass along, or short-circuit a request. The order is critical because requests flow forward and responses flow backward through the pipeline. For example, exception handling should be early, routing must happen before endpoint execution, and authentication usually comes before authorization. I use middleware for concerns like logging, CORS, static files, authentication, and custom request processing. Be sure to mention pipeline ordering, request and response flow, next delegate, short-circuiting, common middleware examples, and why ordering affects authentication, routing, and error handling. Question 9. How would you design a RESTful API in ASP.NET Core? I design APIs around resources, not actions. For example, get/orders, post/orders, and get/orders ID. Controllers or minimal APIs should accept DTOs, validate input, and return meaningful status codes like 201, 400, 404, and 409. I separate domain models from API contracts, add pagination for collections, and use consistent error responses. For production, I include authentication, versioning, logging, correlation IDs, and Swagger documentation for discoverability. While answering, focus on resource-based routes, HTTP verbs, status codes, DTOs, validation, versioning, authentication, pagination, error responses, and OpenAPI documentation. Question 10. What is Entity Framework Core? And how do you avoid common performance issues? Entity Framework Core is an ORM that maps C# entities to database tables and translates link queries into SQL. The most common performance issue is accidentally loading too much data or triggering N+1 queries. I use projections with select, include only when needed, and as no tracking for read-only queries. I also inspect generated SQL, add proper indexes, keep DB context short-lived, and avoid treating EF as magic, because database behavior still matters. Make sure to cover DB context, change tracking, link translation, migrations, eager versus lazy loading, N+1 queries, projections, indexes, and as no tracking for reads. Question 11. What is the difference between IEnumerable, IQueryable, and list in .NET? IEnumerable represents a sequence that can be iterated, usually in memory, and supports deferred execution. IQueryable extends that idea for query providers like EF Core, using expression trees so the provider can translate operations into SQL. List is a concrete in-memory collection that has already been materialized. The key interview point is timing. Calling to list executes the query immediately, which is useful when intentional, but expensive if done too early. In your answer, talk about deferred execution, in-memory versus provider-backed queries, expression trees, database translation, materialization, and when to list should or should not be called. Question 12. How do you handle exceptions in a .NET application? I handle exceptions at the right boundary, not everywhere. Inside business code, I catch only exceptions I can recover from or enrich meaningfully. At application boundaries such as ASP.NET Core middleware, I log errors and convert them into consistent responses. I avoid swallowing exceptions and use throw rather than throw X to preserve stack traces. Validation failures should usually be handled as normal control flow, while unexpected failures should be logged and surfaced safely. Be sure to mention specific exceptions, global exception handling, logging, preserving stack traces, custom exceptions, validation versus exceptional flow, and API-friendly error responses. Question 13. What are delegates, events, and func or action in C#? A delegate is a type-safe reference to a method. Func and action are built-in delegate types. Func returns a value, while action returns void. Events are a controlled way for a class to publish notifications to subscribers, commonly used in UI, messaging, or domain events. For example, an order-placed event can notify email and inventory handlers. Delegates make behavior pluggable, but events protect publishers from external code invoking the event directly. While answering, focus on type-safe function references, callbacks, event-driven programming, multicast delegates, built-in delegate types, lambdas, and practical examples from UI or domain events. Question 14. How do records differ from classes in modern C#? Records are designed for data-centric types, where value-based equality matters. Two record instances with the same values are considered equal, unlike normal classes that default to reference equality. Records also work nicely with init-only properties and with expressions for non-destructive mutation. I use them for DTOs, commands, query results, and immutable models. For entities with identity, behavior, and lifecycle, I usually prefer classes because reference identity is often more appropriate. Make sure to cover value-based equality, immutability style with expressions, positional syntax, reference versus value records, DTO use cases, and when normal classes are better. Question 15. How would you implement authentication and authorization in an ASP.NET Core API? Authentication answers who the user is, while authorization decides what they can access. In an API, I commonly use JWT bearer authentication from an identity provider like Azure AD, Auth0, or Identity Server. ASP.NET Core validates issuer, audience, signature, and token expiry. Then I enforce access using roles, claims, or policy-based authorization. I keep tokens short-lived, use HTTPS, avoid putting secrets in tokens, and model permissions around least privilege. In your answer, talk about JWT or cookies, identity provider integration, authentication versus authorization, claims, policies, roles, token validation, HTTPS, and least privilege access. Question 16. What are solid principles and how do they apply to .NET development? Solid is a set of design principles for maintainable object-oriented code. Single responsibility keeps classes focused. Open-closed encourages extension without modifying stable code. Liskov substitution protects correct inheritance. Interface segregation avoids forcing clients to depend on unused members. Dependency inversion makes high-level code depend on abstractions. In .NET, these show up through services, interfaces, DI, and clean boundaries. I apply solid pragmatically. Too many abstractions can be worse than simple code. Be sure to mention each solid principle briefly, connect them to maintainable C# code, dependency injection, interfaces, testability, and avoiding over-engineering. Question 17. How do you improve performance in a slow .NET application? I start by measuring, not guessing. I check logs, traces, database timings, CPU, memory, allocations, and external dependencies. In .NET apps, slow performance often comes from inefficient queries, missing indexes, excessive allocations, synchronous I/O, or chatty service calls. I use profiling tools, inspect SQL, add cache-in where data is stable, and reduce unnecessary object creation. The best optimization is usually removing wasted work, not micro-tuning code blindly. While answering, focus on measuring first, profiling CPU and memory, database queries, async I/O, caching, allocation reduction, logging, connection pooling, and avoiding premature optimization. Question 18. How do you write unit tests for .NET code? I write unit tests around small deterministic units of behavior. A typical test follows arrange, act, assert. Set up inputs and mocks, call the method, then verify the result or interaction. In .NET, I commonly use XUnit, NUnit, or MS-test with mock or N substitute. Good tests avoid real databases, clocks, and networks unless they are integration tests. I focus on business rules, edge cases, failure paths, and async behavior. Make sure to cover test frameworks, arrange, act, assert, mocking dependencies, testing behavior, not implementation, async tests, edge cases, and separating unit tests from integration tests. Question 19. What is the difference between task, thread, and ThreadPool in .NET? A thread is a low-level operating system execution unit. The ThreadPool manages reusable worker threads, so the application avoids constantly creating expensive threads. Task is a higher-level abstraction representing asynchronous or parallel work, usually scheduled on the ThreadPool. For I/O-bound work, async task often does not need a dedicated thread while waiting. For CPU-bound work, task run can use ThreadPool threads, but I avoid overusing it in ASP.NET request handling. In your answer, talk about abstraction level, async work, OS threads, scheduling, ThreadPool reuse, CPU-bound versus I/O-bound workloads, and avoiding unnecessary thread creation. Question 20. How would you structure a maintainable .NET application? I structure a maintainable .NET app around clear boundaries. The API layer handles HTTP concerns. The application layer coordinates use cases. The domain layer contains business rules, and infrastructure handles databases, messaging, and external services. Dependencies should point inward, so core logic does not depend on EF Core or ASP.NET directly. I use DTOs at boundaries, centralize configuration, add logging and validation, and keep projects testable without requiring the whole application to run. Be sure to mention layered architecture or clean architecture, separation of concerns, domain logic, infrastructure boundaries, DTOs, dependency direction, configuration, logging, and testability. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.